This is your pre-lab video for the gravimetric analysis for bismuth lab. Bismuth subsalicylate is an active ingredient in Pepto-Bismol tablets, and the theoretical content of the bismuth subsalicylate is 262 milligrams per tablet. But we're not going to trust them. We're going to experimentally determine how many milligrams per tablet are contained within the tablets that we test in the lab. How are we going to do this? Well, first we're going to liberate the bismuth and then precipitate it as bismuth phosphate and do a gravimetric analysis on it. Gravimetric analysis is an analytical technique that uses the mass of an analyte, or whatever you're looking to determine its amount quantitatively. You're going to do that by mass. The procedure is to start out with 10 tablets of the Pepto-Bismol, or a generic Pepto-Bismol tablet, and record the mass of each of the 10 tablets and then calculate an average. You'll then grind these tablets with a mortar and pestle, nice fine particle size, and get most of it into a beaker, and then record the actual amount that you were able to obtain in the beaker. You'll then react it with hydrochloric acid with this reaction right here. So here's our bismuth subsalicylate molecule, reacting it with hydrochloric acid to make salicylic acid and bismuth oxychloride. Now, bismuth oxychloride is insoluble in neutral and basic solutions. However, since we are doing our reaction in hydrochloric acid, it's an acidic solution, and it too then is soluble. So we will have some bismuth ions in solution. You're going to vacuum filter this solution, and it's going to have some solids in there from the tablet, all kinds of different things that were in the tablet that we don't really care about. What we care about is how much bismuth is contained within this. So when you filter it, the material that you're very interested in is the filtrate. It's the liquid, okay? And we're going to just get rid of the solids. It's important that you use the correct filter paper for this, and these will be marked. After filtering all of that solution, you need to get into a 250 volumetric flask. So you're going to be very careful. You're going to rinse your flasks and rinse anything that your solution touches and get it all into that 250 volumetric flask. Here's our apparatus. For safety reasons, these like to tip over, so we like to clamp our sidearm flask or our vacuum flask to a ring stand. This will connect to an aspirator, and that provides the suction or the vacuum, and we will filter our material. So in this first step, we're going to get rid of the solid material once it's rinsed fully. So we want to make sure all of our bismuth gets into our flask here, and then this will be discarded. So now we have a 250 milliliter volumetric flask that contains all of our bismuth ions, and we are going to react 50 milliliters of it with sodium phosphate solution. And this is a precipitation reaction because we make a solid product. And then we were going to filter again. You have to record the mass of the filter paper because when you're done filtering, you'll be removing the filter paper and all of the bismuth phosphate and putting it somewhere so that it can dry over the next week. And when you come in the following week, you can record the mass of the filter paper and the bismuth phosphate and just subtract off the filter paper. It's nearly impossible to get all of the, well, it is impossible to get all of the solid off of the filter paper. And we need to know its exact mass. Again, make sure that you have the correct filter paper. And if some of the material, some of the bismuth phosphate, does go through the filter paper and end up in the filtrate, you'll see that. You'll see it's cloudy. You need to filter it as many times as you need to so that it's perfectly clear. And you'll be filtering it through the same piece of filter paper. Next week, you will come in, record the mass of your filter paper and the bismuth phosphate, and you'll have your dry mass of bismuth phosphate to move on to your calculations. So you'll have a mass of bismuth phosphate, and just with a molar mass conversion, you can convert that to moles of bismuth phosphate. Grams divided by grams per mole gives you moles. Since this is a 1-to-1 ratio of bismuth ions to bismuth phosphate, this is also the same quantity of your moles of bismuth ions. This is the number of moles that you have in that 50 milliliters that you pipetted over. So we want to divide by the volume that we used, 50 milliliters, to get the concentration of bismuth in that total solution. So moles of bismuth ions divided by the 50 milliliters gives you a molarity. Then you're going to multiply that by the volume that was in the entire flask. So you want to know the moles of bismuth in the entire 250 milliliter flask. So now we will take our concentration times the total volume this time to get the moles of bismuth in the entire flask, or in all of the entire sample that you weighed out originally. Since there's one bismuth ion in the bismuth subsalicylate molecule, when you calculate the moles of bismuth ion, it's equal to the moles of bismuth subsalicylate in the original mass. It's almost the 10 tablets, but it's really just the mass that you were able to get into the beaker. Once you have moles of bismuth subsalicylate, you can convert that into grams using the molar mass of bismuth subsalicylate again. Now we have grams. Grams of our active ingredient in the original mass of the sample that we weighed out. If we divide this by the original mass of tablets that we used, we have a grams of bismuth subsalicylate per gram of the tablets that we used. Multiply this by the average tablet mass, and you'll get the grams of the bismuth subsalicylate per one individual tablet. And you can convert that then to milligrams and compare that to the advertised strength on the package. Safety for this lab: you do want to support your vacuum filtration apparatus with the ring stand and the clamp so that we don't have this tipping over, but all solutions can go down the drain. We are working with some hydrochloric acid. It's a 2 molar hydrochloric acid, so be careful with this. Try not to get it on your clothes or your hands or your body at all. Make sure you clean up your spills and keep your hands washed. And this concludes your pre-lab video.